Today's episode is sponsored by InfluxData, purpose-built for handling time series data at massive scale for real-time analytics.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. Today we'll be talking about time series data and really how to turn data into actionable intelligence. And I know that is a topic that our listeners are really interested in learning more about. And my guest today is Evan Kaplan, who is CEO of InfluxData, a leading time series platform. Evan is an entrepreneur and technology leader with nearly 25 years of experience in the CEO role. And Evan's career spans from creating startups in his own garage to leading NASDAQ-listed companies generating nearly $200 million in annual revenue. Prior to InfluxData, Evan served as executive in residence at Trinity Ventures and president and CEO at iPass Corporation, the leader in global Wi-Fi connectivity. Evan, thank you so much for joining us, and I want to welcome you to the show.
Hey, thanks for having me. I'm looking forward to it.
Wonderful. Before we jump into our discussion, Evan, can you give our listeners just a bit more background about you and InfluxData?
Yeah, sure. So I think the background around me is I've been in the technology space for all too long, really, my whole career, starting in aerospace and then getting deeply into software and networking and specifically security. And then over the last 8 years into data. And when I joined InfluxData, I joined the company in 2016 when we were pre-revenue. And so I've been there 8 years now. And that's a natural bridge into what InfluxData does. And the company started out working primarily on time series data, which is still what we do today. And it started out, our founder, Paul Dix, my partner in this whole enterprise, worked on Wall Street, building a number of time series databases on existing data platforms for Wall Street firms. And he is a big open source fan. And he developed the conviction that this needed to be a lot easier and a lot more sustainable for developers. And he came out in late 2013 with the first open source InfluxDB. And InfluxDB is a time series database. So it's really meant to capture measurements of time at scale. And so the notion is that, it was easy to understand in terms of Wall Street and stock trading. You have all these variables and trades and all that sort of stuff, high frequency traders. And so you're constantly looking at latency and time of transaction. But it also, because I'd come from the networking space and understood a lot about IoT, I also felt very strongly that this was, the perfect technology for IoT. And the reason I think that is because sensors, in whatever form they are, whether they're machines or smart cities or healthcare or transportation, speak time series. That's their lingua franca. That could be pressure, temperature, volume, humidity, all of those things combined, but they're all about measurement and instrumentation. And so I felt very strongly with the IoT revolution just sort of beginning to take shape that InfluxData would be relevant. So today the company has 1 million active instances of InfluxDB that run daily. We have 2,500 commercial customers. And in this space, specifically large companies like PTC, Honeywell, Rockwell, use InfluxData, as well as a lot of startups in this space use InfluxData as the foundation for their time series, their measurement data. Sorry for the long answer, but hopefully that answers both questions.
Yeah, and I was going to ask you about your customer base. So you said you work with everyone from the smaller and mid-sized manufacturers as well as large manufacturers. Is that correct?
That's right.
Yeah. And I think, we were talking a little bit before we started the podcast, and I shared with you our audience is comprised of all size of manufacturer leadership, from the big OEMs to the smaller and mid-sized manufacturers. And one of the things that the small and mid grapple with is their understanding of how to gain access to what they might feel is enterprise class technology or processes because they think it's cost prohibitive or too complex. So are you able to talk a little bit about how you handled those types of discussions with your customers?
So in terms of us handling the discussions, really the customers are coming to us with, I would argue that there are two broad orientations. And you, Amy, may know more about this than me, since our platform is largely horizontal. It's not only used in manufacturing, it's used in energy, it's used in oil and gas, it's used in finance, it's used in telcos, it's used horizontally. And so feel free to dive a little deeper on the manufacturing front. But what our view of the manufacturing space is really interesting, because we're an open source orientation. And there are, literally over 1 million people who run this stuff daily. And lots of those are in manufacturing. I would take a bet that it's 15% in manufacturing who are running that in the open source format. You see this broad trend, and it's early, and maybe because you cover the 30 under 30, you may see this is, I'll call these two camps, we used to talk about them as IT and OT. But I think the dividing line in manufacturing, and near as I can tell, looks something like platform versus composable orientation. And what I mean about that is, historically, large platforms have dominated this industrial IoT world. And it's the classic large platforms you'd expect. Honeywell, Siemens, PTC, lots of large players dominated, and Rockwell continue to dominate these spaces across the different verticals. And, largely the people in OT would buy these platforms, and they'd be instrumented, and they'd be tied to equipment, and it'd be pretty deeply vertically integrated. With the next generation, and I can't say it's the younger generation, I'll just say it's the next generation, there's a much more composable orientation towards this smart manufacturing piece, which is we assemble components and we build solutions. And I think the AI revolution actually makes some of that a lot easier, to be honest with you. But the orientation is more towards these, let's call them these operational capabilities, but where developers are doing the work, where you literally have developers who are employed by these large manufacturers, building systems that are fit for their use cases and tighter fit, and they're less lock-in, and they're more capable to build. But it requires building that capability versus just buying a platform off the house. And so the build versus buy broadly is changing. That's kind of our view. And I think it's somewhat disruptive of the larger platforms. So, Amy, you're close to this. I don't know if that would be your assessment too, but we see this dynamic happening. And that's where we tend to be successful, where people take our database and then they build the capability. They take things like MQTT, they take things like Node-RED, they take, visualizations like Grafana, and they build solutions that replace either traditional historians or other parts of the manufacturing process.
So let's talk a little bit about some of the characteristics of time series data in IIoT settings. And from your perspective, why is it so difficult to manage this type of data?
So first of all, there's a at some crude level, it's not that difficult. Time series data has existed in manufacturing as long as computers and databases have existed. If you built a smart manufacturing application 40 years ago, you might have built it on Oracle or IBM DB2. If you built it 20 years ago, you might have built it on an open source platform like MySQL. But if you built it within the last 5 to 7 years, you've built it on a time series platform, ours, or maybe even one of our competitors, right? Because what you've seen is that you are trying to solve a couple of problems at once. You're trying to collect the data as fast as you can so that you can get it as real time. And what I mean by collecting it as fast as you can, as soon as it's basically collected from the endpoint, it's available to read. So it's available to make a decision on or based like that. So you're trying to get closer and closer to real time. Normal databases just aren't very good at that. Secondly is you're trying to get super high resolution. So you may want, you could take a single measurement in time, but want to look at, basically 100 different variables. What was the climate on the factory floor? What was this process? What was the temperature? How much light was in the room? I mean, the more descriptive you can be about what's happening, the more intelligence you're building over time. And so as you get more descriptive, you're collecting more variables, you get high cardinality data. And when you get high cardinality data, it can be very hard to query that data at any kind of scale because it can jam up a database. So the more high resolution data you have, the more specialized you want your platform to be. I think this is generally becoming accepted. And then lastly, you want to be able to take action on that data. So if you see a process, you don't want to just have to notify a human every time there's a process happening. You want to be able to issue actions. Again, the requirement for more real-time, super high performance changes. And so like anything else, the more sophisticated you get, the more specialized the tools become. It just so happens that time series is such a broad category within manufacturing. Everything is dependent on this instrumentation, collection, and action sort of loop, that it turns out that this is sort of takes up a lot of the space that traditional databases would have taken up a long time ago.
Great. So walk me through and walk our listeners through how InfluxData's platform addresses those specific challenges of managing time series data in both smart manufacturing and IIoT settings. So you take this complexity and how do you address those challenges of handling massive amounts of data in real time to empower real-time decision-making and better decision-making?
So some of that is us addressing, but some of our community is addressing. So when I say community, because we're open source, we have a project called Telegraph. And Telegraph basically is a collector on I forget what the number is, some like 300 different systems that are available. So first of all, you have the ability to collect and format the data very quickly so it can be ingested by the database at the speed that you want. So Telegraph can do that. There's also an API within the platform that allows somebody to build it directly into an application. And I will tell you, these are not hard things to do, right? We're known for being very easy for developers to work with. Secondly, is the database itself is schemaless. So you don't have to know exactly how to structure your data when you're collecting it. Because it's schemaless, you can take an opinionated view, and that opinion can change over time. And so it allows you the flexibility because, right now a system's doing one thing, but it could need to do other things. And the way you collect the data and the way you organize it may be different over time. And then the third thing is this notion of cardinality is like, as I get more sophisticated with my systems, I want to become more descriptive. And when I become more descriptive, I don't want to lose the performance I have. Maybe I need 50 millisecond response time on these queries. I don't want to lose that the more descriptive I can. And by having a database that handles cardinality really, really well, you're basically protected from that dynamic. And then the other thing I didn't mention is also what happens is because you're collecting high resolution data, you often don't want to keep that around for a long period of time. You want to summarize that data, what we call downsample it, and keep the historical record maybe every minute as opposed to every 3 seconds or 1 second. And so the ability to evict data fast is actually really important. Now, most databases don't evict data, right? They're meant to keep the data. And so evicting fast really kills the performance. So everything has to do with basically being able to operate at real real time with high resolution. And so if you build a platform that does that, you're uniquely suited for these industrial IoT applications. Other things too, but industrial IoT specific.
Yeah, that's a really interesting point about evicting the data. I haven't really heard much conversation around that, but I would imagine, you have partnerships with some of the leading players in IoT. So that's an important piece. Can you give our listeners just a couple of examples of how these customers are using InfluxDB?
Yeah, I think it's I'm going to say this in a funny sense. It's a generic use. They're all using it. They're all using it to do fundamentally the same thing with different performance. So they're all using it to capture sensor data coming off of machines, processes. These could be chemical processes, not just discrete manufacturing, right? They're all using it to capture data coming off of sensors and machines and to process that data in a relatively fast period of time to either do reporting through applications or to basically alerting to other people or to take actions. It's a relatively, I know that doesn't sound as sexy, but it's relatively harmonious across the different sectors. And so, we could talk, I could give you some examples of, that, Tesla uses it to collect data from Powerwall. PTC uses this for discrete manufacturing processes and ThingWorks. But they're all basically the same idea. And there's an old, Amy, I don't know how familiar you are, but historically, you're familiar with OSI soft.
Mm-hmm.
There's historically in manufacturing, there's been this concept of a historian, which is basically collecting this time series, which is a historian is a time series database. It's just that typically it's not a modern time series database. It's not built for all these kinds of things that happen in real time.
So, and when we talk about intelligent manufacturing systems, what role does time series data play in those intelligent manufacturing systems?
It's great. Yeah. I think there are three discrete components. So one is, I don't think we are I'll say this, and I don't mean at least today, we are not the creators of intelligence. The creation of intelligence happens, it can happen in an enterprise's lakehouse. It can happen in models within specific manufacturing, machine learning models, things like that. I think that's where intelligence gets built. It gets built in these other data stores that bring together not just the machine data, but maybe the business data that marries to the machine data, maybe the unstructured data and the structured data comes together in a common place, and that gets turned into machine learning models that then get turned into intelligence. We do not play that role in the creation of intelligence. Where we play a role is, first of all, on the front end. In order to have that data, you have to be able to instrument your systems very easily and collect that time series data. We're superb at that. We're just unbelievably good at it, collecting it at scale, at pace, billions of points a second, and not exaggerating. Billions of points a second coming from whatever. So if you can imagine, any sophisticated process, right? The more you can instrument it, the more valuable. So we're great at collection. We're also great at organizing that data so it can be put into the intelligence, the brain, if you will, into the machine learning models and stuff like that. So having a model for tags and fields that allow people to say, I want to select on this data to pull it into this model in this rate, that sort of stuff. So we're very good at the organization. And lastly, most importantly, because we're operating in real time on both sides of the equation, we are great at basically driving action. So if you have the data and you've built the intelligence model, and the intelligence basically model can say, hey, listen, when you see this particular condition, always act like this. We're very good at taking that action because the action is driven by fundamentally a query to the database. And the database has to respond in milliseconds, ideally less than 50, less than 10, in some cases, really even smaller than that. And so if you want to build a system that operates in real time, you have to build around data handling that can be this fast, this dynamic. And so that's where we tend to be really, really good. And then we depend on others to build the raw intelligence.
So let's talk a little bit about recent advancements of the InfluxDB platform that were developed maybe to meet these evolving needs of smart manufacturing companies. It's such a fast-moving space when it comes to smart manufacturing. There are all sorts of new KPIs that people are being asked to measure, even when it relates to energy efficiency. I mean, there's just everything has to be measured, but outside of real actionable insights, measuring for the sake of measuring doesn't do anything. But, how are you seeing this landscape evolving with new advancements coming out?
So let's start with what you just said, which is everything has to be measured. That's like our holy grail, right? that's what we're great at, instrumentation. You build, and how do you build intelligence is you start with instrumentation, you watch a system perform in real time, you look for behaviors, and then you re-instrument based on those behaviors. And so if you do that 4 billion times, you have a self-driving car. If you do it, 400,000 times, you've got an elite smart manufacturing line, right? So you can just see this is the loop. You instrument, you observe, you re-instrument, you observe, and you're building corrections. And what you're trying to get is to systems that are self-healing, self-learning, eventually autonomous, right? Everybody wants to get to autonomy. Not all systems need to be autonomous, but everybody wants to get there. So yeah, with our 3.0 product line, I've mentioned a bunch of them: the unlimited cardinality piece, the faster performance times, all of that. We also have what's really important in manufacturing is what we call an edge version. So basically, a monolithic single node that can sit on a factory floor or be isolated, be tied to a specific machine, be tied to a specific process, whatever. So what most people are doing in data is saying cloud is everything. And you shouldn't be worried about everything should go up to the cloud and back. Obviously, that doesn't work for real-time stuff. And for security cases where you've got you've got processing things that are super vulnerable, a lot of times you want to keep that stuff on premise. So we're about to roll out, probably later this quarter, our edge version, our open source edge version of our 3.0 database that has all that sort of stuff. I think that's the most important thing in the manufacturing that we're doing, in addition to the normal stuff I talked about, performance and cardinality.
Yeah, you mentioned earlier that part of your background has been in the security space, which is such an important topic for manufacturers as it relates to smart manufacturing and everything being connected.
Yeah, I think it's incredibly important, and I think this is also why you see these smart manufacturers increasingly employ talented developers and technical people as opposed to operators. That technical basis for understanding what your risk, what your surface area risk is for all these devices, all these things you're doing is important. Separately, nothing to do with manufacturing development, but lots of our customers are security vendors, as you'd expect, because what they're looking at is, incident management, where incidents are coming in or queries are coming in or things are coming in that look suspicious, and they're measuring and timing all that sort of stuff. So we have a lot of customers in the security space.
Yeah, that makes a lot of sense. So as you look ahead, what do you see as, the future impact of time series data management in smart manufacturing? And where would you say the next series of roadblocks, of challenges will kind of occur, and how will things like InfluxDB help solve those challenges?
It's true of all human design systems, but it's really easy to understand in manufacturing. What all human design systems want is they want to be increasingly intelligent, and they want to operate in real time. Those two dynamics are, let's call them the two irrefutable forces. That if I build a system, I want it to be more intelligent, and I want it to operate more and more in real time, because we're trying to go on that journey from anomaly detection to self-healing to autonomy, right? All systems want to do that. Now, whether they all have to do it and how fast they have to do it, that's questionable. But a manufacturing system that can heal itself and correct for errors quickly is obviously going to be the ideal. Is obviously going to be the ideal frame. And so when I see that all starts with instrumentation. And so what I see is that in manufacturing, that I see this, by the way, in reality, that customers are getting much better at instrumenting all of it. So back to your question about KPIs, I think they're instrumenting not for KPIs, right? KPIs are just a natural output. They're instrumenting for system performance. And I think the work of the future is how do I take my discrete process and make it continually smarter? How do I build intelligence and then get it to operate in real time? the more I can do that, and basically this is the AI revolution writ large, right? The more I can do that, right, the better I can perform and the better my business performs around it. I think, how do we help solve that? I think it's relatively clear. We want to be the expert at instrumentation and operation in real time. That's where we spend our dollars. That's why performance is so important. Cardinality is so important. All these things are really important. We want to give these people to instrument at will without much friction.
So we've covered a good bit of ground. Is there anything you think it's important for our listeners to know, especially as it relates to, turning data into actionable intelligence, as you mentioned in this era of artificial intelligence and IIoT? If there's a go-do someone could take away from this conversation, what do you think that might be?
Yeah, I think there is. I think there is some go-dos. I think if I'm running a mid-size shop or a large-size shop, I want to make sure I've got good technologists on the front end. I think there is, I really want to invest in good technology people who understand how intelligence interacts with these systems and how do we build an intelligence framework. I think a lot of when people talk about AI now, a lot of it's really about Gen AI, which is really about the digital world. It's about language, it's about video, it's about, increasingly about all those. But I think the real expertise as it comes to manufacturing is really the stuff that traditionally machine learning is. We're going to see a big sophistication, the jump of machine learning, the ability to run those things at scale. And I think if you don't have people, I don't think you can just hire consulting firms for this. I think you have to have people who understand your business, who are capable of interacting with these models, learning on these models, and applying these models. And I think it's a long run dynamic. I don't think it's something you're going to solve in a year or two, but it's something that I think as a manufacturer, you have to start investing in now. Do I have the right technologists, and how am I building intelligence? Right? Not even how am I operationalizing it yet, but how am I building it? And I think that's really important. And so I'm less interested in the KPIs and the benchmarks. Of course, if you're running a manufacturer, you need that. But I'm much more interested in how I'm building intelligence and how do I find the people who can help me do that. And it's not like they're in gigantic supply. You have to work hard, or you have to cultivate them or build them.
And I think that's an area where a lot of manufacturers are struggling, is with not just talent retention, but understanding what roles are needed and where to invest those dollars for the future, especially as it relates to hiring good technologists. And I think we could, more conversation needs to happen as an industry around the roles and the skill sets, and are those trained? Can those be trained within existing team members, or do you have to go out and find them? And how can companies really crack that code, because it's a big topic right now?
I think it can't. Probably not one or the other, and it'd be interesting how many of your 30 under 30 would fit into those.
Yeah, it's an exciting time for manufacturing. It really is. There's it's this juxtaposition of, even when we talk about, the people who hold the keys and all of the knowledge in the physical brain of someone, right? And the new breed of manufacturing workforce and talent coming in that are technology natives and digital natives, and coming together to see how things can work together and learn from each other, but, certainly evolve. People talk about the industrial, quote unquote, revolution. It's really an evolution. It's a slow moving industry, we know, but it's got to move. So it's such an interesting phenomenon to bear witness to right now. It's an exciting time for manufacturing.
Oh, it's just an amazing time. It can sound like overhype, but everything to do with building intelligence, not just manufacturing, is going to describe the rest of our professional careers. It's easy you can describe the rest of my professional careers, but it'll describe the rest of your 30 under 30 professional careers. It's just so important, that intelligence building pipeline. Not to say the other things aren't important, but it's the thing that will drive, the future.
Yeah, I love that. I love that phrase, intelligence building pipeline. It's a very interesting topic.
Yeah, and it's kind of a meta topic within manufacturing too, right? It's not just It doesn't describe one specific thing. It's really the expertise that needs to be. And it's like we've watched this, throughout my career, we've watched different revolutions in manufacturing, but I think this is the most profound and the most sustaining that I think we'll see. It's probably certainly I'll see in my career.
Absolutely. Mine as well. Well, you will do the 50 under 50 and the 60 under 60, and we'll see how that goes.
I think the number should go down the higher up you go.
No, 10
right?
under 10.
It should
That's
be like
where
who
we're headed.
survived. It should be, right?
Yeah, I
Who
know.
survived?
It's so true.
That's funny.
Well, Evan, is there anything else you think it's important for our listeners to know?
No, I think you got the sense of it, how we're thinking about the world. I mean, to summarize quickly, is you're trying to build a database that's really purpose built for this kind of next generation of stuff. You're trying to capture this distinction of having a developer-oriented manufacturing process as opposed to off the shelf. And you're trying to capture what's happening with this manufacturing intelligence at scale. So I think that's kind of summarizes my thinking about a lot of this stuff.
Well, Evan Kaplan, I want to thank you so much for taking the time and joining us and sharing your valuable insights with our listeners. And if people want to learn more about the work you and your team at InfluxData are doing, where should they go?
The website's the clear and obvious place. Yeah. We try to put as much information and resources. There are manufacturing specific resources. There are customer examples, stuff like that.
Okay, so everyone go check out InfluxData.com. There's some great resources. There's a great blog, really good use cases, so valuable information there. So I want to thank, again, Evan for joining, and I want to thank our listeners for tuning in. Make sure that you stay up to date about what's happening in advanced and smart manufacturing, and hear more podcasts by visiting us at advancedmanufacturing.org.